Now in this video, we move on to level 3, that is intermediate. If you haven't watched the first part and the second part, I would highly recommend you to go and watch them, but you're more than welcome to continue with this video. In this video, we will look at the relative speed that is between two moving object or bodies. Now this question is taken from lower division assistant, that is 2025. That is question number 14. Now from the question, a train is 150 meter long. So the length of the train is 150 meter long. So this is the first object. So let me write here, train 1, the length or the distance equal to 150 meter. And it's running at 60 kilometer per hour. So 60 kilometer here is the speed per hour. So speed equals 60 kilometer per hour. Now if the man is going at 6 kilometer per hour, so the speed of the man is 6 kilometer. Let me write here, the man, the second object, and his speed is 6 kilometer an hour. Now they're moving in the same direction, so we need to find how long. So we need to find the time. How long will it take for the train to pass the man? So we need to find the time. How long would it take? What option is given? Is it option A, option B, option C, or option D? Now in order to solve this question, you need to know certain concept. The first one is, if two objects are moving in the same direction, let me write here, same direction, we need to subtract their relative speed. When I say relative speed, I mean we are comparing one speed relative to the other, meaning how fast or how slow the speed is going. So based on that, it is called relative speed. If they're moving in the same direction, we need to subtract those values. But if they are moving in the opposite, let me write here, if the question asks if they're moving in the opposite direction, then we will add those values or add their speed. So speed 1 plus speed 2. But in this case, on the question, the two objects are moving in the same direction, so we'll use this formula, which is relative speed equal speed 1 minus speed 2. So let's do that. And we will use the formula of time, which I hope you still remember, time equal distance over speed. So distance we already know, which is 150 meter, which is the length of the train. What about the speed? The speed here is in kilometer per hour, same case for the man's speed. So we need to change their unit from kilometer per hour to meter per second. So speed of the train is 60 kilometer per hour minus, from this one, relative speed 6 kilometer per hour of the man. Now the relative speed would equal to 54 kilometer an hour. Now let's change the unit from kilometer to meter per second. I'll be using this fraction, which is 5 over 18, which enabled me to change it to meter per second. 18 ones are 18, 18 threes are 54, 5 3 would be 15 meter per second. And we can use this speed up in our formula, which is time equal distance over speed. So it'll be 15 meter per second. Meter here will be cancel. 15 1 would be 15, so that will be 10. So our time equal 10 seconds. So it take 10 seconds for the train to pass a man who is running 6 km per hour. So option B is the correct answer, which is 10 seconds. Now we move on to question number 15, which is relative speed in the same direction. Now question number 15 is similar to question number 14, and if you have understood question number 14, you could easily solve this question. So I'm leaving this question for you to solve, which is number 15. And once you solve it, you can comment down your answer. Now let's move on to question number 16. Now from the question, walking at 4 km per hour. On the question given, walking 4 km per hour. So this is the speed. Mr. A reaches his office. Let me write here, office 5 minutes late. 5 minutes late. If Mr. A walks at 5 km per hour, so walking, but this time the speed is 5 km per hour. Let me write here, speed 2, this is speed 1. He would be 4 minutes too early, so same distance, which is his office, but this time he was 4 minutes early. So how far is his office from his house? So how far it is the distance. So we need to find the distance. Option is given. Is it option A, option B, option C, or option D? And the options are given in kilometer. So we need to be mindful of the unit. Now, in order to solve this question, we need to identify the pattern. We need to ask ourselves these questions. Is the distance changing? So distance, is the distance changing? In this case, no, because he's walking the same from his house to his office. So the distance is the same. What about his speed? Is the speed changing? In this case, yes, because in the first speed he was walking at 4 km per hour. In the second speed he was walking at 5 km per hour. And whenever you see in the question there is X minute late and Y minute early, we need to add this value. In our case, that is true because we have 5 minute late and 4 minute early. Now this allows us to compare the travel time. Let me write here, travel time. And we need to add these value. So it will be 4 minute plus 5 minute. That will give me 9 minute. Now what this means is that the slower journey, in this case 4 km, takes 9 minutes more than the faster journey, which is 5 km. One. Next, we need to convert our minute into hour. I already told you, our option is asking us in kilometer. In kilometer, always go with hour. So I need to make them the same unit. So I need to change my minute into hour. So whenever I move from the smaller unit to a bigger unit, meaning from minute to hour, I need to divide them. So it will be 9 minutes over 60 minutes. Because in a 1 hour, there is 60 minutes. So I need to divide this value with 60 minutes. So 3 would be 9, 320 would be 60. So it'll be 3 over 20 hour. So our next step would be to use the time formula, which will look something like this. Time equal distance over speed. Now we don't know our distance, so I can write let distance equal d kilometer. Now time at 4 km per hour, I can write time here at 4 km per hour, distance over speed, which is 4 km per hour. What about time at 5 km per hour? So the time equal distance over 5 km per hour. Now we can move on to form the equation. Since 4 km is slower and it takes more time, so I can write distance minus distance 4 km per hour, 5 km per hour equal our time, which is 3 over 20 hour. Notice that we subtract the travel time, not the distance. Now let's solve this equation. I need to find the least multiple of 4 and 5. So 2 would be 4, 2 ones are 2, 5 ones are 5. So it'll be 2 multiply 5. That will give me 20. The least common multiple would be 20. I'll be right here 20. If you're confused, you can simply need to find a number which, when we multiply, give me the least common multiple. So if I multiply 4 times 5 would give me 20. I need to do the same case with the numerator. So it'll be 5. Multiply both the numerator and denominator by 5. So they'll give me 5 over d. Same case with this one. 5 times 4 would be 20. 5 times 4 would give me 20. And same case with the numerator. So that'll be 4 over d. 3 over 20 hour. This one is kilometer per hour. So 5d minus 4d, that would give me 1. So I can write d 20 kilometer per hour. 320 hour. I can multiply both sides by 20. So 20 kilometer per hour. Multiply 20 kilometer per hour. 20 here cancel. 20 cancel. Kilometer per hour. Hour here cancel. All we have is kilometer. So distance equal to 3 kilometer. So this is our final answer, which is 3 kilometer. If we take a look at the option, we see that option B is a correct answer, which is 3 kilometer. Now we can use the shortcut method to solve the same question. The shortcut method only worked when we have the same distance. So let me write here, the distance is the same. Distance is the same. And there's 2 different speed, meaning 2 different speed are given, which in our case it's true. And the question If the question have late and early, ERLY, early time, we can use this formula, which is distance equal difference in time times speed 1 multiplies speed 2 over speed 2 minus speed 1. So let us plug our value. Difference in time, we already know it is 3 over 20 hour. Our speed 1 is 4 km per hour times speed 2, 5 km per hour. Speed 2 is 5 km per hour minus speed 1, 4 km per hour. So far would be 20 km per hour. So 3 over 20 hour. 5 minus 4 km per hour, that will give me 1. So I don't need to put the value of 1 in my numerator. 20 here cancel, hour cancel. We have 3 km. So our distance equal 3 km, which give me the same answer. In exam, it is advised for you to use this formula, but be careful of what the question is asking. You can only use this formula. I already told you, but I want to repeat it. If the distance is the same, meaning the journey is the same, there's two different speed. Right here, two different speed. And in the question, there is late and early mentioned. Then and only then you can use this formula. So yeah, that's it for this video. Thanks for watching. See you in the next one.